Aviation safety systems are more complex than most people realize. A single landing calculation involves over 50 different variables that could mean the difference between a safe touchdown and potential disaster.
That's fascinating, and it really makes you wonder how pilots manage all that complexity in real time, especially during emergencies.
Well, that's where modern technology comes in beautifully. These aircraft have sophisticated systems like ecam, the Electronic Centralized Aircraft Monitor, which essentially acts as an intelligent assistant. But here's what's really interesting. Even with all this technology, pilots still need to make crucial judgment calls.
Hmm, so how exactly does the system help pilots navigate these critical moments?
So when there's an issue that could affect landing performance, the system displays landing distance procedure apply, telling the crew they need to verify their landing calculations. And get this, they have to input various factors into what's called the landing performance application, which then calculates something called V-approach.
Oh, tell me more about V approach. What makes it so important?
Well, V-approach isn't just a simple number, it's actually calculated using this complex formula, VREF plus something called delta VREF plus approach corrections and potentially an additional pilot adjustment. And here's the kicker. If all these adjustments add up to more than 20 knots, pilots are actually advised against adding any more speed.
That's exactly the kind of precision I wouldn't expect. You know, most passengers probably think it's just about pointing the nose down and slowing down.
Right, and that's just the beginning. The approach corrections take into account things like whether the autothrust system is working, if there's any ice accumulation, and the headwind component. But here's where it gets really interesting. Sometimes these calculations show they might need more runway than initially planned.
Well, that sounds like it could lead to some pretty intense situations. What happens then?
That's where the ROW system, runway overrun warning, comes into play. If it indicates they need more runway length than what's available, pilots have three options. They can try to get special authorization to deactivate the ROW system, request a different runway, or make the tough call to divert to another airport entirely.
So, if we think about the evolution of these systems, how has this changed from, say, 20 years ago?
That's actually a fascinating point. These procedures and calculations are the result of decades of experience and, unfortunately, sometimes learning from incidents. Every calculation, every procedure, every safety margin has been refined over time. For instance, the way we calculate approach speeds today is far more precise than even a decade ago.
Like a constant process of refinement and improvement, building on past experiences.
Exactly, and what's particularly interesting is how all these safety systems work together. The ROW system isn't just a simple warning light, it's integrated with multiple aircraft systems and can take into account factors like runway conditions, weather, and aircraft configuration to provide accurate warnings about potential overrun situations.
You know what really strikes me about all this? The incredible balance between human judgment and technological assistance.
That's right, and it's crucial to understand that these systems are designed to assist pilots, not replace their judgment. Modern aircraft are incredibly sophisticated, but they're built to provide pilots with the information they need to make informed decisions, especially in critical situations like landing with system failures.
And I imagine this technology continues to evolve with new innovations.
Without a doubt, the aviation industry is constantly pushing the boundaries of safety technology. We're already seeing developments in artificial intelligence and machine learning being applied to landing calculations and performance predictions. But what's fascinating is how these advancements are always designed to enhance rather than replace human expertise.
That really puts things in perspective. Next time I'm on a flight, I'll have a whole new appreciation for what's happening in the cockpit during landing.
And that's really what it's all about. These incredibly complex systems working together seamlessly to ensure that passengers can safely reach their destination, usually without ever knowing the sophisticated dance of technology and human expertise that made it possible.